Alrighty. Well, we're here, Singular Podcast, here to talk more at Commodity Classic. We're very excited and have the honor and privilege to have a gentleman that we met. What was it over? What'd you call it? Barley farming?
Yeah, we were barley farming
Or
in Broken Bow, Nebraska.
Yeah. So we were doing quality check.
Yeah, quality check at Kincaid's Brewery.
Kincaid's Brewery, yeah. So one thing I'll ask Robert is, gosh, your story is so great in your avenue throughout the industry. Fill us in about what you're doing today and influence on agriculture.
Well, I mean, my entire life, the only thing I've really ever done that's been consistent has been plants. And I always had a strong love for plants, and I worked up mainly through the service industry, where we do a lot of agronomy work, planting, nursery work, turf grass, and things like that. And I was always interested in the study of how the plants manage the environment, or how they respond to the environment. And that led me down the path of hormones and plant hormone physiology. That's now years. I think I'm going on. Actually bumped into an old friend from grad school here just yesterday, and we were talking. So 24 years ago, we used to give presentations together in grad school.
Okay.
And so now I'm still in the industry. My focus today is on the use of plant growth hormones and making different mixtures of plant growth hormones to balance very specific stages of growth to increase uniformity, production, and ultimately grower yields and ROI on the farm. I think where we're a little bit different, my company today is called Ag America, and where we're really different is we're farm-based, and we're farm from the farmer to the bottle. So we'll go work with farmers. That's how we met in Nebraska, some mutual contacts, and we'll look at their fields, we'll figure out what's going on, and then we'll design solutions to fix their problems in that field.
Awesome. And then also, Mike, introduce yourself. I just met you yesterday. Would love to know more about your history and introduce yourself.
Well, Mike Llewellyn, and I started this long walk in the agricultural field in 1974. So it's almost 51 years now. I've seen a lot of improvements. I've seen a lot of things happen throughout the industry, some good and some not so good. But that's why about 10 years ago started.
Okay.
Hang on just a second.
I need you guys to eat the mic, like almost touch it. And
Okay.
Yeah.
Because he's going to have to go in and crop her voice out of this thing.
Oh, I got you.
You know, they came down and started loading all the luggage right there.
If you're right here, I'm hearing everything.
I got you.
So I have to have you guys so hot if it's down here that we're going to pick up everything.
Gotcha.
Okay.
Sorry.
Eat the mic. It's just part of it. Do you want to start with just Mike introducing himself again? Okay. Awesome.
Okay, Mike Llewellyn. I've been in the ag industry since 1974, mostly in the fertilizer, micronutrients, and the last 20 so years in the dealing with hormones and stuff like that in plants. I've seen a lot of good, and I've seen a lot of not so good. Have my own manufacturing facility now. I call it Crosslink of New Mexico. And it's why I say that is because I cross boundaries and I'm linking the past with the future. And that's how I came up with the name.
That's awesome. I love that name. Well, maybe to get in the meat and bones of things, I mean, the one area, Robert, that I listened to you and I said more farmers need to hear this. It was the plant hormones and how easily easily to absorb in. So maybe just start on your talk, and I'll ask questions along the way. Mike, please chime in wherever you have additions. Don't feel like you need to hold back. I mean, that's not what we're trying to do here. So, Robert, if you could go ahead and open door. It's open door.
Well, the plant hormones are really they're the plant brains. So there's been a few great guys in the past, and they would say the roots are the brains of the plant. And that's because about 80% of plant hormones are made in the roots of the plant. And there's 5 basic hormones, cytokinin, auxin, gibberellin, abscisic acid, and ethylene. And the combinations of these hormones is how the plant decides what the environment is doing to it.
Okay.
And then based on that combination, the plant can then respond and manage the environment.
Okay.
So the plant can't get up and run away. It can't go into the other room. It can't close the door. So it uses these chemicals to change its growth, to put its carbon and its sugars in the right places, so it's doing the right thing at the right time during the right conditions.
Okay. Okay. So let's just start when the seed's in the ground.
Okay, so
Okay.
the seeds, when you're in the ground, there's two main hormones that are really affecting the seed and keeping it dormant or making it germinate, and it's called abscisic acid, and that's really the sleeper, the dormancy hormone. And then there's gibberellin, and that'll make things wake up. It makes them imbibe water, and it's much more of a juvenility hormone. So when you put a seed in the ground, it's full of ABA.
Okay.
And that ABA starts to break down, and that water from imbibition allows the plant to start germinating and growing, and the GA starts to spike, and that's when you see your cotyledon emerge and elongate right up out of the soil, so it can make some green tissue to start making its own food.
Okay. So when you say GA,
I'm sorry, gibberellic acid.
okay.
Yeah.
So with that, what are some things that a person can influence, or maybe what should they influence, or maybe what they shouldn't influence when it comes to plant hormones at that stage?
Well, so you have to think of each seed as an individual. And every individual, it might all be corn or might all be soybean. That kind of looks the same. But just like me and you, we have different hair color, different eye color. Your seeds in corn seed, it's going to be the same thing. So it's important when you first grow any crop to get really good uniformity of emergence, and that leads to uniformity of growth. Because yield is not made on an individual plant basis. Yield is made on an acre. So it's really the uniformity of that acre that allows us to maximize the yield in our fields.
Okay.
So I'm not against gibberellin. That'll actually make the plants and all the seeds germinate a lot quicker, but it has a tendency to make your plants tall and skinny.
Okay. Yep.
And in certain conditions, that's not a good effect. Where we met up in Nebraska, the wind never stops blowing.
Yep.
And if gibberellin makes your plant tall and skinny, you have problems with lodging, and you don't have a super highway to bring those sugars into the root system. It's narrow, and it seems to constrict it.
Okay.
So we like to treat seed with a balanced hormone profile.
Okay.
And we're typically
So like the word balance, let's dig into that then. Like, what components are with that?
Well, when you're in vegetative growth, it's more than just gibberellin. That would be an imbalance. It would tell the plants that they're crowded. It would tell the plants that they were planted too densely, and it'll make them all reach for the sun.
Okay.
So we would prefer something more balanced with some cytokinin, auxin, and gibberellin, and those are your vegetative hormones. So that tells the plant that it was planted correctly. It tells the plant that it's going to grow, it's going to pop out of the ground, but it's not going to be tall and skinny.
Having said that, it's very important of the ratios of these hormones at particular times.
Okay.
And that really makes a difference. And that's what separates hormones from hormones. It's the ratio that you put those three in.
Okay.
Very important.
Okay.
Yeah, because there's any single hormone in a high dose is potentially a herbicide.
Okay.
But when you balance these hormones so that it matches the physiological stage of that plant, then it's really a growth promoter.
Okay. Okay. So balance. I mean, we talk about that in soil health. It's just so important.
It's everything. It's
Yes.
absolutely everything.
Okay. So the seeds came out of the ground. Okay. So we had a balanced approach with cytokinins, auxins, and gibberellins, correct?
Yes.
So I first think of sea kelps. That's what they talk about a lot with having those three. Now, I know one thing that we dove in is there's different types of sea kelps and there's different sources of sea kelps, correct?
Yes, on the last call, absolutely.
Yeah. So maybe dig into that a little bit and how that profile is influenced with that hormone imbalance based on where you source that sea kelp from.
Well, I love kelps and kelp-based species, and even some of these algae-based hydrolysates.
Okay.
And you really have to think about this. Why would a hormone guy love a kelp-based product? So kelps are plants, seaweed, really. I mean, let's just oversimplify this.
Yes.
And think about where seaweed grows.
Okay.
We're in an ocean. We have high sun. There's no shade in the ocean. So we're constantly getting beat up on by the sun. It could be very hot at one point and very cold at another. And, well, there's salt everywhere just trying to rob moisture from the cell.
Yep.
Some of these species of kelp they're not open ocean. They're more on where the waves break.
Okay.
And there you'll have tidal activity, and part of the day they'll be submerged. Part of the day they'll be drying out on the sand.
Gotcha.
And so how the kelp responds to this is by producing different hormones to protect itself from the rapidly changing conditions in the sea.
Okay.
And different, just like our plants, you have different weeds in different fields, and some places I grow wheat, other places we grow grapefruits.
Okay.
And these plants, they have different hormones and different hormone profiles, and so not all kelps are considered equally.
Okay.
In some environments, this certain species, like in Ascophyllum, for instance, this is it's an active kelp. It's growing quickly. It has a lot of those vegetative hormones.
Okay.
Those cytokinins, those auxins, those gibberellins, and they can act as very good growth promoters. Now, other kelps in different conditions, maybe like a Saccharina japonica, they're growing in a much different area where the hormones they're using are more of the late season or the ripening type hormones.
Okay.
So you might see a high load of ABA, high loads of cytokinin. We even find really high amounts of salicylic acid, which is an accessory hormone that's
Okay.
known for plant defense in that species.
Okay.
You'll even see things that are not true kelps, and they're more of a freshwater algae
Okay.
on the market today.
Okay.
And if you think of an algae growing in a swimming pool, it doesn't have roots. It just has leaves. So cytokinins, they're really responsible for cell division and leaf growth. So those extracts are just loaded in cytokinin.
Okay.
Now, the challenge or issue that we see with this rapidly developing, I don't like the word biostimulant industry, is that we're marketing or we're sometimes using kelp species at the wrong time. So
Okay.
there's a right species for each stage of growth, just like there's a right hormone profile for each stage of growth.
So there's almost overgeneralization within the marketplace right now.
Oh, it is, and everybody's just trying to buy and sell a kelp. And kelp is different. It'd be like trying to buy and sell a corn or a soybean plant. They're both great, but there's different uses, different qualities, and different times to apply these in the field.
Well, and I think that transparency is so key. I guess my question is, Robert, you've been in this field for so long, and it's easy to rattle it off. So let's just pretend that I've never met you, okay? And I said, what do I need to do on my corn crop? Or what should I be looking for on a label?
Oh, on a label of like a sea kelp type product.
Yes.
So you first and foremost, you want to know the species of kelp it's derived from. There's at least a dozen that are traded commercially and used, just in the fields that we walked last year. So first, identify the species.
Okay.
And once you identify that species, you'll be able to figure out what the hormone profile of that kelp package is.
Okay.
And from there, you can match that hormone profile with the right time of application.
Okay.
And I do a lot of work with a Saccharina japonica kelp, and it's a late season ripener.
Okay.
I want to use that late in the season to help my crop dry down uniformly. I want to use it to directly manage that gibberellic acid we were talking about, to keep my plants short and fat and productive. But I don't want to use that product when I'm looking to rapidly establish growth or
Okay.
to rapidly close a canopy. Now, some of the other kelps on the market, the most popular, I would say, is Ascophyllum. It's the most largely traded.
Okay.
And on that kelp, for instance, it's much more of a growth promoter. So
Okay.
I use that to increase the rate of development of the plant. And, alternatively, if I was using that later in the season, that might slow down my harvest and slow down my ripening.
Okay.
And depending on where you live, that might be a really big problem. So a kelp out of place is really a hormone out of place, and you have to be aware of that. In terms of maybe quality too, different kelp hydrolysates have different contents of amino acids, different contents of saponic acid, which is a stress-reducing product.
Okay.
Some of them are neutralized with hydroxides, and they might be high in calcium or high in potassium.
Okay.
And then another one that's completely overlooked is there's tons and tons of these trace elements that come from the ocean.
Yes.
And they're not all considered plant essential nutrients, but they're likely very beneficial.
Yes.
I got a question. Rob, on these kelp products, would you say the market needs to explain their products a little bit better so we'd know how to, use them effectively?
Oh, absolutely. And then I guess maybe I'm just too involved in it. But when I see a product that's just, this is kelp, apply kelp, it's ridiculous. It'd be like me telling you, well, you got to apply fertilizer. Well, what are we applying? NPK, calcium, zinc. It's such a broad generalization, and it's not always a good condition for the farmer. So a farmer's now going to use kelp. I mean, that's a night or day difference.
Well, and it's just so important of understand. I mean, it's more than just biostimulants. It's everything that's on the farm, making sure we understand intentionality with that product, right?
Absolutely.
Because a lot of times I sit here as an agronomist making recommendations. Like, there's trials that I want to do, but I also want to know if that trial doesn't work, what was going on, instead of just going blindly into it. What are some possibilities of it working the way we thought it would, or if it doesn't, being able to start rattling, okay, these are the options, not just saying, well, it didn't work and walking away. That's not how I work.
Oh yeah, no. And it ruins a really good product for everyone.
Yeah.
So if we're using the kelp out of place, now you're going to think, oh, kelp doesn't work.
Yeah.
And now, but it was user error, and not necessarily the user's fault, because the label's just kelp.
Yeah.
It's
Yeah. So with that, I mean, I'm kind of looking at a 10,000 foot view.
Okay, guys, real quick, we've got a blog and a newsletter. A lot of people don't know that.
Yes, and a bunch of great information, trying to be timely, how that fits throughout that year of agriculture, that we know there's different thoughts going through our heads during different seasons.
We have different people write it. We've got people from all over the United States, different walks of life, that have really cool perspectives that brings so much value as a whole. And you guys can find these. It's at singularagronomics.com under, I believe it's the media portion, or blogs. There's a whole blog. There's a blogs link.
Yes.
There's a blogs link. Check out the link in the description. I'm serious. I enjoy reading those so much, just because you hear from so many cool people that are really, we have someone new write it every month.
Well, yeah, and it's a quick read.
It is.
It's a quick read. Head to the website.
Yeah, check it out.
I understand like what you're saying about the process of finding the right species of kelp, okay? But I'm thinking of my grower right now. He's saying that's too much time for me to start doing that research, diving into that research. So maybe what I'm asking here is, if there was one time to influence with a kelp, where have you seen the biggest bang for your buck throughout the growth of, let's just say, corn and or beans?
Well, okay, then I guess I really then did see. Now you're asking me to kind of put my foot in the mouth here. So let's stop first and say I'm gonna generalize all species.
Okay.
And so there is a time for each species to be applied.
Okay.
But let's just take that variability out of it for the minute.
Yep.
One of the things that all kelps do is they're very good at stress reduction.
Okay.
So let's assume you picked the right species off the bat so that the hormone profile matches that hormone stage in the plant. There's a lot of anti-stress compounds that you'll find in all kelps.
Okay.
So I would apply it at a stressful timing. Maybe that's a herbicide application on a GMO crop. Maybe that's heat stress. Maybe that's tasseling.
Okay.
So these are timings just generally across the board in all plants where they're very susceptible to stress, and that's your major yield limitation.
Okay.
So, and a lot of that are the antioxidants and saponic acids and just generally things that stop the plant stress pathway.
Okay.
Think of a plant's life, right? Yeah, any crop. It's the plant doesn't necessarily have to live to be a successful individual in this world. The plant needs to successfully set seed, and that seed
Yes.
needs to drop to the ground.
Yes.
When's the most stress-tolerant time of any plant? In the seed, in the shell. So when this all goes back to hormones, and when a plant's under stress, a plant makes energy and takes CO2 from the air. It makes sugars, and it does this through, truly a miracle of a molecule, the chloroplast.
Yeah.
And inside there is the chlorophyll, and these are called phospholipids. Really, really simply, phospholipids are like butter. They're literally
Okay.
fat.
Yep.
So when we take that butter out of the refrigerator in the morning, it is hard. And if you try to spread that, it rips apart your bread. Then if you just lay it out, and I'm from Houston, Texas, so if you lay that one out outside for a little while, it's just a pile of oil. And
Yep.
it's equally hard to spread on the bread. Now, when plants are in perfect conditions, the butter's very soft, and the light hits it, and then that light, almost all of it's utilized, and the energy is directed to where it needs to go. But if that butter's a little too hard or a little too soft, there's a lot of extra energy that just bounces off. It doesn't hit the membranes.
Got you. Yeah.
And a plant, even a plant under drought is likely in that 90% water range. So that extra energy hits the water, and it creates hydrogen peroxide. And the same stuff in that brown bottle that you put on your cut and it bubbles. And
Yep.
I have slides for this when I'm up on stage. And those bubbles are the signal for another hormone called ethylene. And ethylene is the ripening hormone, the banana, the tomato, the green tomato turns red. It's a gas, it's really cool. But it's also the stress hormone. So it induces flowering, it induces ripening, it induces ABA, and it helps the plant make a strong seed, and then the plant wins. It sets seed, it falls to the ground, and it lives to fight another day.
Well, and it's so interesting about ethylene. I've seen this one in person. Like, I'll go to a pivot, and there's a little area that maybe water's not infiltrating fully.
Mm-hmm.
So that's starting to mature quicker. But that circle just keeps getting bigger, even though I could go outside of that circle where the new dead plants are and probe, and there's water there. There was water flow, but the hormones itself was expressing, creating that to be bigger and bigger. It goes back to ripening a banana. You get a banana that's over ripened and put it in the same bag as a green banana.
Exactly.
It's slowly gonna turn
Exactly.
there. That's what try to give those examples of what we've seen to understand these hormones.
No, and ethylene's probably the most known of all the plant hormones when I teach classes because of that banana or that tomato example.
Yes.
And think of why, and not the ethylene's really a cool hormone. The hormones are mostly liquids, physical liquids, but ethylene is a gas. And
Okay.
that's important because, if you're under stress across the table from me, there's a good chance that I'm going to face the same condition. So I can respond to your ethylene and start to ripen. So you will see cross-ripening across the field. You'll see it spread by the wind. A gas, doesn't the gas just float away? Well, a canopy, it's a closed canopy in most systems, and that holds a lot more ethylene than you would think.
Yeah.
And we don't need parts per million of ethylene. You're talking parts per billion of these molecules.
Okay.
So another really good one, or you might see stuff like this around gas lights. Some in the fancy neighborhoods, they might have the actual gas lights, or greenhouse growers. That's another one. Sometimes the heaters are misfiring, and they'll make ethylene. Those are hydrocarbons.
Okay.
And then if you want to think about stress, so a good agronomist, they'll get in your field and they'll dodge the question when you're asked to estimate the yield at the end of the day.
Darn right I do.
And if you think about this, where did yield go? So ethylene, all plant sugar is coming in from the air. It's CO2. CO2 comes into the plant. It's turned into sugar. And then when we estimate the yield, that yield is really there. I
Yep.
mean, there really is 100 bushels in those beans.
Yep.
And what is ethylene? It's C2H4. So that's literally where the yield goes. When the plant is under
Oh my
stress,
goodness. Okay.
the bushel floats out of the plant. And that's why your yield estimates are always wrong.
Thank you. Well, Robert, I've been stewing this for 5 years now, and now I know where I went wrong. But that's so interesting because even like this last year on soybeans, we're like, where did yield vanish? Okay, because I would go out there every 3 days and I would do pod counts again and again and again. And the biggest stage where we lost yield was at R6 of soybeans, right at the end.
Very stressful time.
But what was so amazing in my eyes is the number of pods didn't disappear. It's just instead of being a 2.9 pod average, it was down to a 2.
Oh yeah, yeah.
And it goes back to, well, it's taking carbon from something, and clearly that seed had that carbon
the
that it
seed
could take
has the
from.
carbon because it's
Yeah.
a two-way street.
Yeah.
The other thing is, I mean, you talk soybeans, the same thing on corn. We have been to so many different fields and done the counts like you said. We did kernel counts. So you think, okay, I know how many kernels we're going to get. Oh, man, we're going to have a 250 bushel yield.
Yep.
And it's 200. And normally that disappears from I would say on corn, from the milk stage on. You lose yield when it starts filling out that seed. It's going somewhere. Ethylene, or even the plant itself will rob yield from the seed.
Oh, that's a good one to use an example then to bring this back to the kelp opening that we were talking about.
Uh-huh.
And when you made me overgeneralize.
I know. I'm sorry. Sorry.
Think about something like that. If like the soybean plant, corn is a little less prone to it because it's so determinate, but also in the corn plant. So if we were to come in with growth promoting kelp that has a lot of that cytokinin, auxin, and gibberellin that promotes vegetative growth and juvenility, if we were going to use that late in the season, you would actually make that plant that was full of ethylene and APA and wanting to ripen for the year, you could make it go more vegetative and accelerate that loss of carbon from the pod or from the kernel into the atmosphere. Now, if you were using a saccharina kelp that was really high in ABA and salicylic and some of these late season hormones that promote dry down, you could actually stop that new trifoliate development and you can preserve yield potential.
Okay.
But if we don't have that information and we're just using, hey, get some kelp on there, it's hot out, you could be doing damage to a crop with actually a very good product at another time of year.
Okay. So really hit that kelp part. I want to get back to the auxin and cytokinins.
Oh, yeah.
Okay, let's talk a little bit more about those two in depth. We hit ethylene, on which I wanted to hit that, but I want to hit those two because it seems like a lot of the market right now, we're talking about those two.
Yeah, I'd say that those are major hormones, and to some extent, maybe even gibberellin. But cytokinin and auxin, they're different. Auxin would be the great initiator of a cell, and if you have an auxin application, you'll typically get a new cell. Now, cytokinins, they don't develop new cells. What they do is make cells divide. So if you had 1, you'll have 2, 4, 8.
Okay.
It's an exponential growth. So that's what the cytokinin does to the plant. And these two are going to balance each other. This goes back to what you were saying, Mike, earlier. and they balance each other to determine what the plant's going to be. So a cytokinin dominant plant, or using a cytokinin dominant product, that's going to promote more of a leafiness in the plant. It's going to create more centers to do photosynthesis. Where our auxins, those are going to promote things like new flowers, new root tips, and yeah, so the balance then between the two of those is what's going to determine the physiology of the plant. Maybe timing.
Okay.
We like something a little bit more auxin dominant in those early vegetative stages.
Okay.
To really start to set that crop. And then once we're going into division stages, maybe like at V6 when we're setting rows and columns, you can hit it with a cytokinin application. You can completely increase the number of cells in that kernel, and that would increase your density. If you do it at V6, you can actually increase your rows and columns.
Okay.
So, but auxin at that time would not have that same effect.
Okay, so something that I always think about too is when you when you apply plant hormones, if you do not have the fertility underneath it to support it, you can make that plant overdrive and almost put on too much that it can't support it. Would you agree or disagree with that?
It's so cool. And we, most of my career was in more academic pursuits. I went commercial probably about 12 years ago, and then we started Agmerica 7 years ago.
Okay.
A good mentor of mine passed away, and went out and started this company. And but yes, so you have to think of it like your truck.
Okay.
These hormones, they're the keys to the truck. And your nutrients and even micronutrients, that's the fuel in the tank. Now, hormones, they're going to increase the rate of development. One of the greatest time to put like a cytokinin, auxin, gibberellin package into the plant is right on that seed, because it's changing the rate of cell division, like throwing gasoline in your fire, and it's making everything burn quicker. Now, the signal's going to go away. It's not going to stay
it's
forever.
not gonna stay there. Yeah.
But the rate that you set is going to continue for the life of that crop.
Okay.
So now you're actively transcribing your DNA and growing faster. So when you feed that now with your 17 nutrients, then it's going to perform amazing things. You'll get bigger plants. You will get some of those really big yield bumps that some of these large companies will market. Now, the problem becomes old von Liebig. So von Liebig made a barrel, and that barrel says that you're only going to grow as big as your most limiting nutrient.
Yep.
And now, if you need more nutrients, you're going to get limited by that lower barrel stay.
So it gets back to the point of balance, not only with hormones. If your nutrition levels are not balanced, or if you had yield limiting factors that you can see on a soil test, let's correct those first before you start pursuing plant hormones. Would you agree or disagree?
I would do it as it's
combined effort almost.
Combination.
Combination.
Yes.
Okay.
It is a tiered approach.
Yeah.
So you want to make sure the fields, and I mean, we talk about hormone balance because hormones I'm always thinking about hormones, but it is your nutrient balance, your soil balance. I mean, even the carbon in the soil and the organic matter, that helps bind up and keep a lot of nutrients in the ground. And so farming is a systems approach, and you really shouldn't just ignore any one stage.
Okay.
So we not only have to balance the nutrients, balance the hormones, but we have to balance the nutrients to the hormones.
Yes.
So.
Okay.
And one of the things we have found out using the hormones is using a micronutrient mix in combination. We have seen where just putting hormones out, because they won't last in a plant 2 weeks, Rob, maybe 3 at the most.
And thank goodness, you really have to say that, because hormone, what is an unregulated hormone? Or I'll say the S word, which is not a good word for the formulators, but what is a stable hormone? these are herbicides.
Yep,
The
100%.
entire class of the phenoxys are all they're stable hormones for to oversimplify that as well. So yes, the hormones and things that you're applying, they'll typically they'll have a signaling effect real quickly, and then the plants will quickly metabolize them, and then quickly they'll be deactivated or destabilized. A lot of these nutrients can direct, and even amino acids, like some now we're seeing a lot of amino acids in this general category, but these are precursors to hormones, or they support systems that make hormones. So, those you can dictate hormonal effects with nutrients by preloading them as well. I know in my field programs, I'm really heavy on calcium, boron, molybdenum.
Okay.
Calcium really helps stabilize the auxins and give you a good auxin response. So we might partner this with auxin, with tryptophan. These are
Okay.
precursor, auxin itself, and then tryptophan is a precursor to auxin, and then add that with some calcium, and that can really get a nice hormone response with very little actual auxin. The auxin is immediate. You'll see it that afternoon. The tryptophan you'll see the next day, and the calcium will kick in 2 to 3 days. Equivalently, we're big on boron. Boron's kind of cool because every hormone has an equal and active hormone deactivating system.
Okay.
I like to think of it like that old Pac-Man game
Yep.
we used to have. And there's a Pac-Man for auxin. It's called IAA oxidase.
Okay.
And boron is a really cool nutrient because it kills Pac-Man. And the plant just makes these normal levels of auxin, no problem, but Pac-Man's dead. So it builds up, and you can dictate a hormone response. A cool example might be just, go find yourself some boron salts out there, throw some on a plant, and you can actually get what appears to be a 2,4-D or a dicamba
Yes,
type
100%.
response.
Yes.
A lot of times that's just because you killed Pac-Man, and now that soybean plant's grown and it has too much auxin and it needs to rebalance it. And,
Okay.
so, yeah, you not only pair these hormones in the right ratios and concentrations, but you also have to do that with your foliar nutrients.
Okay. Well, and I think that's something that there needs to be a part 2, because I know we could probably talk another 45 minutes strictly on nutrient balance with hormones. But before we wrap up here, anything else you would like to share about plant hormones, or if there's something that we didn't cover that you think needs to be on part 1?
Well, I think we should really stress that the plant has a crop stage from when you sow that seed in the ground to when you roll the combine and you rip these seeds off the ground. And they're going to change. And the ratios are going to be what's important. The ratios to one another is going to tell the plant, what stage it should be in. And so as we go over the course of the year from start, then to finish, it's important to use the right hormone and micronutrient packages at the right times so that we're working with the plant growth cycle and managing that cycle so we get the most out of the input ingredients that we're using. Because it's not really about just adding more to get more. It's about being efficient and adding what we need at the right time to maximize that true genetic potential of that plant.
Awesome.
Yeah, I think it's so important at the seeding time because your yield is determined at germination. And that's why these seed treatments are so important with your hormones and maybe a micronutrient package or whatever at that time, because if you come up with a weak stand or a weak seedling, we've seen in the fields and we've flagged them to where at the end a corn stalk won't make an ear.
Okay.
So,
yeah.
It's the more uniform you can get your germination and the strength of that seedling, the better the crop is going to be, and that is hormonal and nutritional at the same time.
Yes, to maximize the the stability, the ratios. That's a good point. I think this year what we've been seeing a lot of winter times. I mean, all three of us, we're in farm barns and we're developing nutrient plans. And this year, more than others, the major question I've been getting from our clients and our friends is, man, what can I cut this year that's not gonna make an impact? And because they're trying to, it's a tight budget, and they're trying to keep it lean this year. And the one thing you don't want to skimp on is that early season. I mean, a seed treatment is great for a farmer, and it is bad for the company. That is the most efficient way for you to get your active ingredient exactly where it needs to be, when it needs to be there. Start that plant off strong and right, and it'll grow at that rate that year. So, I mean, if you're going to start to cut things, you don't cut up front.
Okay.
You start strong, you cut later.
Okay. Well, awesome. Robert and Mike, thank you so much for making this work today. I know I said there would be a part 2, just so the fans know, or our listeners know, I should say. Not sure when part 2 will be, so don't be sitting here saying, when's part 2, but we'll make it happen. How about that?
I'd really like that.
Yeah.
And it doesn't take much to get us to talk about what we love. So
That's exactly right.
we'd love to get in here and do we'll do a whole series.
There we go.
See what bothers us. We can even follow the season, so these are relevant to the guys listening to it, because you can't remember everything forever. You know?
Yeah. Well, I know I'm going to be re-listening to this episode over and over again, because I know I'm sitting here right now and I'm already ready to re-listen to it. So
yeah, this is great. And thank you for inviting us and Agmerica, and we're here to support you, and more importantly, we're here to support the farmers.
Awesome. Well, thank you so much, and that's a wrap.
Okay, thank you.
Thank you.
Guys, thanks for watching the content so far. If you would like to see more, be sure to subscribe to our YouTube channel. We've got all the full-length podcasts, other video information, tutorials on there, also on all the major podcast platforms and social media sites, Facebook, Instagram, TikTok, etc. So if you like this, go ahead and check more out on all those platforms.